Hi, everybody. For this project, our group consisted of me, Jack Maggio, Caleb Hennessey, Parker Walter, Kailyn Kilroe, and Caleb Bowens. And we chose to do our research on the 1886 earthquake in Charleston, South Carolina. For starters, this earthquake occurred in Charleston, South Carolina, which is located along the eastern coast of the United States. The date and time the earthquake struck the city was August 31st, 1886 at roughly 9:51 p.m. Since Charleston is located near the middle of the North American plate, earthquakes of this magnitude are relatively uncommon and referred to as intraplate earthquakes. Scientists believe that this particular earthquake was caused by an ancient fault deep in the earth that most likely formed around the time Pangea split. The image here is to show you where Charleston is located in the US. So you can see it right here with the big red dot. And this picture is a map of the tectonic plates around the globe. And as you can see, Charleston is located right here on the US map, and it's not near any plate boundaries. So earthquakes there are relatively uncommon.
So this earthquake had a very interesting impact on human life. It consisted of a lot of damages, including 100 known deaths, 5.5 million in infrastructure damages, wells and water lines were destroyed, and many other things that happened during the time. And for political and social unrest, it caused a lot of racial tensions, and it caused a complete growth in segue Jim Crow laws in the future. So it was rough on a lot of different times. 1886.
There are actually a lot of environmental impacts. So this earthquake also allowed scientists to discover a way to measure the seismic waves of the quake and the strength of the quake, which is really helpful for future earthquakes. This work solidified the view that an earthquake entails the passage of waves, elastic compression through the Earth's crust, and also effectively buried the competing shrinking Earth theory, which that held a cooling contracting Earth led to earthquakes. So the shrinking Earth theory claimed that when things cool down, it is well known that they shrink. This would cause the solid crust to wrinkle in the same way that the skin of an apple wrinkles when it has been left for too long without being eaten. The mountain ranges of the Earth were thought to be wrinkles of the crust, and this idea was well accepted in scientific circles. The shrinking Earth theory also predicted that mountain ranges would appear randomly all over Earth's surface. It also predicted that mountains would constantly grow higher. Another part of the theory stated that volcanoes and earthquakes would occur at random all over the surface of the Earth. So the 1886 earthquake was followed by a series of aftershocks of about 435 or more earthquakes were reported to have taken place in South Carolina within 1754 and the next 200 years. More than 300 were aftershocks that occurred in the first 35 years following 1886. The 1886 earthquake and its aftershocks dominate the seismic record of the Southeast. It was also found later on that a series of earthquakes were a result of this Charleston earthquake. The Woodstock fault was associated with the larger earthquake in 1886. Also, most of the current earthquake activity is along the Ashley River fault, which was about 2.5 to 4 miles deep, running close to the river near Middleton Place in this area. And the Woodstock fault is a horizontal fault, 5.5 to 8 miles deep, running between South Carolina, and this was thought to be a result of the Charleston earthquake at the time.
So some fun facts about the earthquake is despite being near in the middle of the North American plate, South Carolina is a common spot for seismic activity. The people of Charleston thought that God was inflicting his wrath upon them when they were hit in the earthquake of 1886, since they had previously been ravaged by the Civil War and a hurricane. And though it is 5 times bigger than it was in 1886, Charleston expected to be hit by another earthquake of a similar magnitude sometime in the future.
And these are just our sources that we used for our research.
So that's the end of our presentation. Thank you all for listening and have a good day.